This conference will now be recorded.
Okay, so it is being recorded right now. Let me go ahead and bring in Rhino 6.0. Is that what you're working with, Bill?
Yes, that's correct.
Okay. So as Rhino starts up here, your RhinoCam plugin loads, which you're already familiar with. So the mesh is a module that goes into RhinoCam. So we have different modules, mill turn, mesh, net.
Yeah, I saw the mesh. I actually opened it. Of course, it wouldn't let me do anything, but yeah.
Yep. So you would need a license for it. So once it's licensed, if you go to About, you'll see yes right next to it. So if it says no, which means you do not have a license for the mesh mod.
Right.
So let me go find this file here, and I will just drag this into Rhino.
Yeah, it's awful big.
Okay. We'll wait for the file to load. How did you create this file, or how, you know?
Well, just real quick to show you that you have a couple of layers there. You need to turn off, what's the layer? It says like direction 1 and direction 2. There you go. And then unhide or show. The mesh is actually on a layer. It's actually hidden. So if you just go show, there you go. There's the mesh. And then that rectangle can just be whatever, throw it away, delete it, whatever you want to do.
Okay, so you want me to hide it here?
Yeah.
Okay.
There you go.
All right, so we got this mesh here. Okay. Let me go to RhinoCam and then select mesh. Okay. So it has about 5732. So is this making? I don't think this is such a big file here. So there's something else that's causing the file to be really large.
Yeah.
So it's fairly small. If you look at the mesh in terms of, it only has about 50,732 triangles in here.
Right.
Okay. So what are the things that you're looking to accomplish on this particular model, sir?
Well, I'd like to clean it up a little bit. It needs some editing. It's a scan of a hand.
Okay.
And you can kind of see the index finger isn't real clean. I don't know if it's closed. I'm not, a total mesh guy, but I would suspect there might be some openings.
Yeah, we can go under the mesh. There's different tabs, similar to how you have it in your cam. So we can go to repair. And one of the things we can identify is run a diagnostic check on this one here. And, we can just say we want to look for anything that's open, right? So I'm going to clear these boxes in here.
Okay.
Click run. It says there were no open edges on the model.
Okay. So it's closed, all right?
Good. There's a closed mesh. So if there were open edges, it would mark those open edges here. It will tell you how many they are. It'll also display them in this particular color on the meshes.
So let me ask you, Uday, if I had imported just the point cloud from the scan, would it have been able to do this mesh inside the fingers, or is it more of a drape that just drapes it over the top?
No, we actually take the point cloud and create a mesh from it. So,
yeah, okay. So you could do exactly what I have here.
Mesh from point cloud. Once you pick the point cloud, you can actually specify what do you call it as the sampling size and all of that stuff. You can put it in and you can specify it.
Okay.
Create a mesh from point cloud. Would you happen to have the point cloud still on this?
I don't, because when I scanned it, I'm using an older cube scanner, and before I save it, it allows me to make it solid. And when I did that, I lost the points from that file.
All right. Okay.
And I wasn't aware of that. I'm just kind of starting to scan and do some of this stuff, so I wasn't aware of. And I have two different scanners, and that one was actually able to make a mesh. My other one can't.
Okay.
So, yeah.
So you're looking to do some cleanup on these areas here?
Yeah.
Okay. So if you go back into this tab in here, let's say inspect and modify.
Okay.
This is where you have the tools to either smoothen up a mesh, You can remesh it, where you can specify if I go into the display and then say display the mesh wires, it displays mesh wires right there for you.
Right.
Triangles in the mesh. So I could go ahead and try to, make some changes in here, right? You want to, so you can go ahead and say you want to do a mesh smoothing. You pick the mesh that you want to smoothen out. And you can even localize it to just specific areas if you want to smoothen it. So for example, I can say in the smooth mesh, I can just use a radius in here. I can paint a section, so it'll only smooth out that section right there.
Okay. Oh, cool.
And I can go back and click on it again here to expand. So basically, I just put in a 1-inch radius in here, right?
Okay.
So I pick that area right there, and then I can say number of iterations. I can do 1, 2, 3, or as many, and then basically it smoothens that out right there.
Oh, I see.
So
how would you get rid of this? Yeah, how would you get rid of this part that's sticking out? Can you just delete those, remove those faces, and then smooth?
A split, and then do a deletion. So you may have to. You can actually do a mesh split, or you can create like a plane in Rhino, and then split it with that. So we have.
Yeah, Rhino also has the ability to remove those faces. You can take those faces out, but then you end up with an opening, right?
Yeah, we can do a close then. So we can do auto fix to automatically close it. So if you use a mesh split command, sorry.
There you go.
And you can pick the object to split, and there's no cutting object. So basically, I will have to build something in here.
No, hang on. It's easier than that. Hang on, it's easier than that. If you go to the mesh toolbar, mesh tools, mesh tools, up one, edit tools, you can extract faces.
Yeah, and then do it, delete it. Okay, yeah. So extract faces.
Or delete mesh faces, either one. You have a delete right underneath that. There you go. Yeah, so and I think if you,
we can do that. So that would
be a little tedious. Yeah, that's a little tedious. Process.
But then we can do an auto fix to go close it out. So
right. So I'm kind of curious on what it looks like when you go to close it. So it isn't just a.
Pick those right there, right?
Oops, one more there.
Did I miss? Okay, right here, a couple of more.
Yeah.
Okay, press enter. Okay, I left this one out. Okay, so repeat that. I'll pick this.
Oops. There you go. There you go. All right, now, okay.
So even this one, I can get rid of this if you wanted to.
Sure. Yeah, I just kind of want to look and see how this works. Yeah. I know it's a little tedious, so yeah, okay.
Now that you have this, so now if I go to repair, diagnose, it shows, or when I do a run, you see there's 4 edges that are open. It highlights those edges.
Yeah.
So I
How come? Hang on, just a minute. Now, when you do that and it highlights those, I'm only seeing it. Like when you move it, sometimes it disappears. Like I can see the
display. It's hiding on top of the edge. So if I go ahead and hide the mesh wires, you can see it better.
Oh, I got you. Okay, all right. Okay.
Because it's sharing the same edge. So now
I got you.
I could use auto fix. Just pick that. It automatically fixes it for us.
Yeah. Okay. Yeah, seeing the edges would be fine if you want to turn those back on, the wire meshes or the mesh wires. Yeah. Okay.
So auto fix takes care of automatically fixing any number of holes that you have on the model.
Right. So we could go through and lop off of anything that's hanging out there and then auto fix the whole thing.
And then you can also go ahead and do there's an option to do, mesh smoothing here. I can basically just pick those mesh first, and then I can change my radius in here. Instead of 1 inch, I can say 2 inches radius, and I can just pick the radius option in here. So that basically picks everything in there. So I can either do about a surface along a normal or both directions. And you can choose an option to keep sharp edges in cases where you want to maintain sharp edges. And here I'm not maintaining sharp edges. Smoothen it. You can see how nicely it's smoothened it right there.
Yeah, exactly.
Through multiple times in here. You can do the same thing. So you can use a combination of both Rhino tools and the mesh tools in here to do it. And you have unlimited undos and redos. So if you go in here, you can say undo, redo multiple. It shows all the commands that you did in the mesh as well.
Okay. That's a Rhino command, right? That's not a RhinoCAM.
The undo, redo is a Rhino command, but we automatically add the commands that you do in the mesh to Rhino because you're doing geometry changes in here.
Yeah. Okay. Got it.
So I can also do a remesh. Remesh basically makes the mesh more uniform. So if you do a remesh, I can pick this, and I can specify the edge length in here. Like, for example, if I put in 50 thousandths and say do not keep the sharp edges. So this goes and creates a mesh.
That's a little more uniform.
Makes it more uniform. So this can take anywhere from a few seconds to several minutes, depending on.
And the reason you'd want to make it more uniform is if you're printing it, it's going to come out as a smoother print. Is that true?
Right. It helps in printing. So if it's going to be doing CNC milling, it's not going to be a big difference as long as the mesh is good. So here it's still processing here, as you can see, it's still thinking. I don't know if the distance I put in is way too tight or way too fine, so it's still processing this information for us. One moment, please.
Yeah, no problem.
Okay, so we got this here, right? Okay.
Yeah.
So let me go back in here and do an offset. Okay, so we wanted to offset this mesh. So you want to have like a thickness to it, right? Like a wall thickness?
Well, that's a good question. If you offset it, it turns it into a solid that has.
Well, we offset only closed meshes, not open meshes. But if you want to do offsetting of open mesh, Rhino has some offsetting tools for that. So typically, the offset, the whole point of offset is to create like a wall thickness or a shell. You can do it so when you 3D print or when you want to do it, then you're not basically filling the inside volume completely.
Yeah, right. Okay, all right. So yeah, the offset's not used to make the thing bigger. It's just used to like you said, shell it.
Yeah.
Okay.
So I can do an offset here, and I can choose a distance and then give it a tolerance. So if I put in, let's say, an offset distance of 1 inch, let's say I want to make it a ½ inch, right? 0.5.
Okay. Yeah.
Offset it. It's going to take the model, and now you can see there's a ½ inch uniform offset around it.
Okay. So then, no way to tell.
Count. So it is 87,560. The original was 50,732.
Okay. All right. So you have two different on that layer there where you're at on this little tree that you're at. You have the STL output and you have the mesh 0. Is the mesh 0 the model that is offset? It's a solid, has a
right. The
thickness
STL is the one that you provided, the one that came in from your system. And then the mesh is what we represent in the tree. So that's the mesh geometry. So I've hidden the STL, as you can see right here. I can toggle the display of it. So right now there's only one mesh that's showing, which is already offset. So if I hide this one, you can see that, the original one, and there's your offset.
Okay. Right. So when you offset it, it doesn't take the original one and make it part of the new mesh. It makes an entire new
one. So we don't delete the original one. We retain it. That's how you can do a split if you want to have a wall thickness or do some sort of a splitting. That's what helps you with that.
Okay. All right.
So if I check the size here, it's 32. Yeah, it's a fairly large mesh in here, right? So if I do I probably used a really small value for the.
You did.
Yeah. So I can go back and remesh it with a much larger value. So reduce the triangle count. So I can go ahead and say reduce it by 50% of the amount. So reduce, basically it reduces. You can see now you have your triangles in here.
Oh, yeah. Right, which might make it easier to clean it up a little bit. Yeah.
Right, and then after reducing, I can do a smoothing around. I can say the entire mesh, it'll basically, you're trying to remove some of these sharpness. So you can keep.
So on the iterations of the smoothness, what does that do? It makes it more smooth?
Number of times, you can see now how we eliminated a lot of these sharp features. Yeah, the more you put in the iterations, the number of times it goes through smoothing it out.
Okay. All right.
You can see now it looks much finer from where we started out.
Right. And you can see my scan isn't very good. That index finger didn't pick up very good.
Yeah, you can also model things in Rhino, and then we have an option to convert it to a mesh, or you can convert it to a mesh and you can do a Boolean. Our Boolean tools are very powerful. So if you want to draw something in Rhino, you can combine it with this.
Do you mean you could combine NURBs with a mesh?
You can take a NURBs and then convert it to a mesh and then combine the two meshes
And combine
together.
it. Yeah,
Yep.
right.
We can also individually pick points and do a push and pull and stuff like that. So, if you want to delete this using how we did in Rhino, mesh tool, delete mesh faces. So I can just go ahead and.
Yeah. Okay.
Okay, that looks a lot better. Now we can go ahead and do a repair, auto fix. That fix it right there, right? And now I can do a mesh smoothing just to a localized area. Just pick this model and say, give it a radius in here. So you can pick that area right there. So that was 2-inch radius. It puts a spherical radius. So if I want to change that, I can cancel this out and change the radius to 1.
Right. Okay.
And just go pick this area. I can even make it go smaller. And now I can smoothen it out right there, and you can see it's much smoother.
Right. Okay. No, that's
so those
nice.
Are, the mesh editing tools that you get. There's also what's called a manipulation. So you can basically select the mesh. You can, like how you have your gumball, you can place a manipulator by picking a few points in here, or you can even individually pick faces. Single triangle selections. For example, I can pick a bunch of triangular faces in here. And now I can say place the manipulator on this here. So now I can actually push and pull.
And it'll keep it as a solid.
It'll be a mesh.
Yeah, I'm sorry, a mesh, but it'll be a solid, closed mesh.
Right. Finish and create a new mesh. So it basically added to that existing mesh.
Wow. Wow. That's cool.
Yeah. And then undo works just like how you do it in Rhino. So you have mesh manipulation. I can pick even a radius in here, put that in there, place the manipulator, I'll pick right there. I can drag this up. I can do some fancy stuff here, right? You can see I can.
Yeah. You can rotate it, right? Just like a gumball manipulator.
Right.
Can you change the location of the manipulator? You can place it on the corner or wherever you want.
Place manipulator. You got to change. Yeah, I can pick where I want it to.
Right. So then if you rotate there, okay.
Yep, I can. Yeah. So I actually moved the mesh itself. So I can do So basically, you're selecting. You first have to identify a bunch of faces. So you can pick something in here, and say you place it, and you can pick where you want to place it. And I can basically use the rotate command also right there. You can see right there how it's deforming it.
Yeah. Wow, that's cool. That's great. Yeah, so that lets us clean up the mesh and manipulate it.
Yeah, so this is going to make the mesh ugly here. If I say finish and create, you can see what it did.
Yeah. So. Right, and at that point, you might have to go back and re-smooth it or remesh it or whatever, right?
Yep. So you can do like a push and pull and, certain things that you can do. You can pick.
Right, so let me ask you, Uday, the push and pull, like you can see that index finger it's flat on the, kind of the inside of it. So would you use the manipulator, or could I use the manipulator to make that finger more round? That would be the way to
here in this area?
Yeah, this whole area here, yeah.
So let me give you keyboard and mouse so you can mark it to me.
Yeah.
Keyboard and give keyboard and mouse. Go ahead, sir.
Yeah, so in this area, can you see my?
Yep, I see
this whole area inside of this finger is flat. So I'd like to make it more round, right? Pull it out more round. Would you use your manipulator?
I could do that, but what might work better is if you draw something in Rhino and you can blend that to this model itself. So, for example, if you draw a few curves.
Yes.
And then you can
make a NURBs,
right? Make it a NURBs, and then you can even make it like a pipe or a solid. And then once you do that, you can convert that to a mesh and then do it. So, for example, in Rhino, you can take a few points. And you can basically build that into this mesh. You can
so then what? I understand how to do it on Rhino. To make that NURBs then part of this mesh.
yeah.
I'd have to take
I'll
that
show it to you.
NURBs.
Yeah.
Okay.
So we'll try something out in here. Let me snap to a vertex maybe. Might be better. I'll just go. Well, let me just throw in a curve in here, right? Something like this here. I think it's going somewhere else. Okay.
Yeah. It's actually probably going on the C-plane if you don't have it snap into the mesh.
Yeah, C-plane. I'll snap into the mesh. That would be better, right?
Yeah,
So
I think so.
Freeform curve. We'll pick one of the points, vertex right here.
There you go.
I'm just picking a few points as you see it, right?
Sure. Just kind of shows how it does it, right?
Yeah, so you can work. Maybe right there, right?
Okay.
Right.
Yeah.
It just created something really simple here, right?
Sure.
And maybe I can do a pipe command.
Okay.
Rhino.
Sure.
Give it a pipe diameter.
Oh, that's a great idea. Yeah.
Right. Diameter, I'll put in maybe 1 inch. Okay, that was too small maybe. I can probably change the pipe radius to, okay, right? Something.
Yeah, something like that. Yeah, okay. We get the idea.
And then I can also make it the round. In the pipe, probably I would have an option to basically the end of the pipe cap round, right? So we can do.
Oh yeah.
There you go.
Yeah, there you go. Yeah.
So now I can take this piece in here, right? You can move this around if you need to, adjust it, and then you can convert this to a mesh using Rhino's mesh tool if you want to do that, or you can use the mesh here, convert it.
Okay.
You select convert, give it a tolerance, pick convert. So it's going to go through the process of converting that piece to a mesh.
Okay, so let me ask you, is there a difference between using Rhino and using MecSoft?
Well, Rhino gives you a different set of controls over, the.
No, I mean to create just that one command, to create this mesh, better to do Rhino or MecSoft, or does it matter?
Yeah, if you need more precise control over it, then Rhino might give you more options in there.
Okay.
So this is a tool that we have right here. Now I can go ahead and do a model. I can make sure that I can say check if this has any open holes. Right, so it says there's 428 open edges on that, right? On this one.
Wow. Okay.
So I could run. I can't merge a Boolean if it's open. So
right.
I can do an auto fix. So that'll fix that right here. Now if I go back and check the mesh, it says there are no open edges. The short edges, that's fine, but no open edges.
Right.
Now I can do a Boolean. If you want to even do some bending and stuff like that, you can do that in Rhino. Take advantage of that. Right? If you want to bend it, make it more organic. And now I can do a union, select this object and this object. And the union tools are very powerful. So now this is one object in here. And you can go back and remesh it. You can do a reduce mesh.
Sure.
And then you can remesh it here. And I can put in edge length maybe 0.125 or maybe 0.25.
Yeah.
So that'll go through the process of, you can see it's working on it. There it is.
Yeah, there you go. It's not too bad. Yeah.
And you can actually go ahead and smoothen these out in here.
Sure.
Smooth, select the mesh. And then you can now pick areas that you want to smooth. And I can put in a radius of maybe 0.25. And I can just go pick these areas in here. I can make it 0.5.
Right.
Basically, you can see a little sphere shows up right there.
Wow, nice.
So basically, I'm picking the area, kind of blending it, right? Those areas.
Yeah.
So
Right, I get the idea. Right.
Yeah, so now I can go ahead
So
and
run
say,
it. Yeah, let's see what it does. Yeah. Right. Very nice.
so you can use Rhino tools. See how we were able to kind of model this, right? So I just use a
Yeah.
pipe command to quickly show you, but you can be more creative. You can
Yeah,
make it
absolutely.
more
Yeah, you can
realistic
make it
and
work
see
better
how,
for what I'm doing,
yeah.
right? So then let me ask you on bigger scans, if I'm scanning something that's more room sized, for example, um, is your mesh module able to deal with that?
Well, depending on, it also depends on the number of triangles you have, right? You're working with. So we have customers who use working with even like millions of triangles, but
Uh-huh.
know, if you're working with tens and 20, 30 millions of triangles, then you might see some performance issues. But then, you know, it'll work. It'll take its time to process it. So you can actually
Right.
break it up into sections and do it, and then Boolean them might work better.
Right. Right. Okay.
So those are certain things you can probably look into.
Right. Because one of the things that I'm doing with my other scanner is scanning stairways, for example, or framing of a house so we can put a stairway in there. And I want to be able to pull dimensions, but if it's just a point cloud, you really can't tell what you're snapping to, right? It's millions
Point
of
cloud, you
points.
can actually, you're snapping it to a vertex, right? When you create a mesh from a point cloud, it becomes a vertex, a vertices.
Right. When you create a mesh on it, right? And
You can use the point snap to snap to it as well.
right. But when you have millions of points on top of each other, you don't really know
It is
what you're
really
snapping
hard.
to.
Mm-hmm.
Yeah.
You can create
Okay.
a mesh from point cloud. So we have this from point cloud. You can create a mesh, and then you
Right.
can work with the mesh. So it might be
Right.
easier.
I'm not sure Rhino has those tools. Do you know that they can create a mesh
Rhino does
from?
not have a mesh from point cloud, but yeah, I haven't seen that in Rhino.
Okay. All right.
Yeah, they only have from NURBs, primitives, and then from close polyline.
Right.
Yeah, that's pretty much it.
Okay. All right.
So you can see how we were able to take a NURBS, convert it in even a poly surface, and then blend it in. So you can probably, you could have drawn a bunch of curves in here.
Yeah. Oh,
And lost
absolutely.
it. Yeah.
Yeah, we could clean that up, no problem. It might just be my OCD, but it looks so much better when all the triangles are about the same size there too.
Yep. It makes it much more uniform as you see it right there.
Yeah. Yeah. Especially if you're going to print it. Although I have a printer, I'm not using it that much for that. Okay. What else? What else can you do? What else do I need to know
we
here?
have subtraction, intersection, intersect and split. We also have offsetting it, and hull is like a shrink wrap, putting a shrink wrap like around it.
Oh, really?
It's not a shrink wrap. Actually, it's just basically just putting a wrap around it. Yeah. And then slicing, you can do a slice. You can pick this model, and it creates. You can say you want to put 25 slices. It basically slices it parallel to the plane that you're in. It creates these slices for you.
Oh,
And
no
you can
kidding.
export them as Rhino curves, the slices.
Oh, no kidding, huh?
And then if you want to actually machine it, you can use them as splitting points. You can slice them, and then you can put it on your sheet to machine it. Right? You have different, because these are all parallel, constant z. So you can basically, try to cut those pieces out.
Right.
So you can export it. That'll be a Rhino curve. Slicing, it also says whether the slicing have any open curves or not. So they're all closed curves. Intersect and split, so you can basically intersect it with any plane and split it. You can even do just splitting. If you do a split, you can pick the object, and then you can say it shows parallel to the plane that you're in right there.
Yes.
So you can put in any plane in Rhino. You can rotate the plane any way you want it, and it'll be parallel to the splitting plane, and then you can say do not cap it and split, so it makes it into two halves. The splitting tools are very powerful.
Wow. Wow, look at that.
So that's your split right there.
Uh-huh.
And if you did a offset and a split, let me back it up here. So let me undo the split. So if I can do an offset here, I'll do an offset of 1/2 inch outside tolerance So basically, it's creating a mesh offset. So there's two meshes in here, and I'm going to select these two, do a split, and I can say do not cap it. So right now, if I don't cap it, it leaves me the gap in there. So if I select these two pieces in here, you can see that there's a wall thickness in here, right?
Right.
So if I say cap it when I split it, it'll actually fill the gap between them.
Fill that gap in, right, right.
So that's
very nice.
Offsetting. You have that with a split. You can also intersect and split with a mesh, with another set of meshes.
Uh-huh.
Just pick those. Right? I deleted them right there.
Right.
So now if I do a manual hole fix, I'll pick this. Detect holes. It's going to detect this hole right here, right?
Right.
And let me hide the mesh wire, so it just makes it easier for us to see it. I can choose how you want it to be. If you say preview, a fan will basically, this is how it's going to put a fix right there.
Mm-hmm.
Or if I can say smooth, so that's going to create a smooth. You see how the difference?
Yeah, I do. Yeah.
Or you can say minimum area, it'll you preview that. And then planar, we'll just do a planar face to fix it. So,
the best it can to get a planar face in there, right?
Right.
So some of those solutions with what we chose are going to look very similar.
Right. So
just depends on what that opening is. Yeah, yeah, right.
And then you can say apply the fix. That's going to add it to the mesh for you.
Nice.
Then diagnostics basically helps you run. And then if you had meshes that you want to like separate them out, there's a piece of mesh that's sticking out. You want to separate it out, you can separate out those mesh. Like you have two meshes, even though they're not joined, they look like they seem to be grouped. You can separate out the meshes, disconnected group of triangles into multiple meshes.
Okay.
And then you can fix the orientation of the triangle. So sometimes your mesh could not be displaying properly. The orientation may be flips. You can fix and flip orientations for the mesh.
So just so I understand, I'm not a mesh guy. That the flip or to fix the orientation, are you saying that you have
the mesh normals will be reversed. The direction of the mesh normals will be reversed. So if you
are you saying the mesh normals or each triangle? So you could have one triangle
yeah.
Okay, next to another one, and they could be flipped inside for outside. Right. Yeah, okay.
So the auto fix takes care of everything. It'll also fix the incorrectly oriented triangles for you. That takes care of it. But individually, if you want to do it, you can use these tools.
So yeah, so if for some reason you want to auger in and do it in an area or do it for whatever reason, in a certain area, you could delineate that by using these other tools.
Absolutely.
Okay, and then the flip orientation would flip the entire thing.
Yeah, flip orientation will be reverse orientation of all the triangles in a mesh. So if they're all pointing towards inside, you want to point them towards outside. It'll just flip the orientation.
Okay, all right, okay.
And then the last tab is a 3D print. This is used if you want to send it to a 3D printer, so you can pick a printer. You can display your printer's volume. There's an XML file where you can basically draws the printer volume. You can choose the part orientation. What is the best orientation of the part to be printed, so to minimize your material, right? And then you can generate supports for it. You can select, and then you can fit the geometry into the printer's volume. You can say fit here. I can pick the mesh. It'll give you the option. I can say put it to bottom center. So it'll give you the model right there.
Okay, so when you have right now you have 3D printer as fabric maker.
Yeah, there's a bunch of lists in here. You can click on it.
Yeah. Do you have Ultimaker in there? Doesn't look like it.
UPI, no, we don't have one, but you can add it. There's an XML file. You can add them. All you need is the volume for the printer, your X, Y, Z, and then the nozzle diameter. If you want to do G code, we can do G code, or we can do STL output.
Really, and you can also STL output it. Yep. And how are you doing that? Are you doing that just as in a save as command, or is that within RhinoCAM?
We do an export right here. It'll convert it, drop up a STL or SLA or AMF format.
Mm-hmm. Okay.
If you want to do supports, you can do supports in here. I can say you want to do support generation for the mesh.
Right, so it has to have some commands to do that, right? Okay, I got you.
Right here gives you the specify the overhang, minimum length, all the parameters in here. To generate. Might take a while for it to create some supports, but it will show you some supports right there.
Oh, look at that. Oh, very cool.
And then once you generate the supports, if you need to modify certain things, you can add support points. You can remove based on the overhang angle. You can click on details. It shows all the information. You can create the supports as a separate mesh, or you can unite it with the base part.
Okay.
Create a mesh. So there will be a separate mesh by itself, supports, and the part right there. And if you want to do an export, you can say export select object. I can just select all of these, and then right click. It'll ask you where do you want to save it, STL, SLA.
Right.
Or if you want to do a print, you can do a G-code generation. So the print.
And then print.
Yeah. Well, export is basically SLA, or if you wanted to generate G-code, you can go to G-code generation.
Right.
Yeah. This will basically bring up a print interface. If you have a print dialog, like a 3D printer configured to your, it'll send it. You can send it to print. That's how you, like a print spooler.
Directly from RhinoCam. That's nice.
And then a generate G code is for, creating like a slicing toolpath. You specify the layer height parameters. Then you can hit generate. It'll compute toolpath, and then you can output the post it out to an NC format or whatever the format is. So it's G code out.
Right.
So
Okay.
this tab, 3D print tab, is more for a printing application.
Right. Well, I do have a printer. We just don't use it an awful lot. That's the thing. Yeah.
The other tabs, what you see here, can be used for both additive and subtractive manufacturing processes.
Right. Right. Okay. I don't know if I have any other questions.
Okay.
But yeah, it's very interesting on what you're doing. So, and I appreciate your time immensely.
Not a problem. So, if you need information about, what does it involve to get the mesh module, and all the pricing information, I can certainly transfer you to Anita. She can get that information to you.
I think I have that right now. I've got to look at a couple other things to make sure that I'm able to manipulate what I have. So that's
okay.
I mean, I got to go back to my other scanner and kind of see how I would use this with that scanner, and just see if it's worthwhile. So, but I have the information. Thank you so much.
All right, no problem.
Yeah.
Is there anything else that you would like to see in the demo here, Bill?
No, I think that's good. I think you you've given me a lot to think about. This is really good.
All right. Okay, so give me one moment. I'll pause the recording here.